Hello everyone, welcome to my YouTube channel. In this video, let's solve one of the quite interesting question. It's easy only, but yeah, sort colors. Okay, so let's understand what exactly is the ask here. Here, given an array nums with n objects colored red, white, or blue. Sort them in place so that objects of the same color are adjacent with the colors in the order red, white, and blue. We will use the integers 0, 1, and 2 to represent the color red, white, and blue respectively. So you must solve this problem without using the library's sort function. Okay, so they specifically mention that we shouldn't use any kind of sort functions. So what they are saying is like they are given as an array. Okay, so and it has n number of objects with n objects colored. So each object have it colored like red, white, and blue or blue. Okay, so these colors are represented as like a 0, 1, and 2 here. So we need to sort them in order such that each and every color which are similar should be adjacent to each other. Okay, so here uh, we need to order it like zeros and then ones then twos. So that's what we call like sorting, right? So here we need to do that kind of sorting. Clear? So let's understand how we can be able to solve this problem. Clear? So sort colors. Okay, so uh, here how we can be able to solve this. They here given nums equal to 202110, nums equal to 202110, something like this, right? So and the output we need to return is with zeros at start, then ones, and then twos, right? So how we can be able to solve this problem, right? One way or the brute force way that I could think of is like, how about if we solve like for every value I will see. Okay, so in the nums is equal to 202110, right? So I will search all the zeros. Okay, so I will find, let's say I will start with I. Okay, and with j I will search all the zeros. So if I find any zero, so I will swap. Okay, then it will be 0 to 2110, and then I will update I and I will continue. So with j, so is it 0? No, then increment j, then increment j, then increment j. Now I find 0, right? So here I will swap with this one, right? Then it will be 0, 0, 2, 1, 1, 2, right? So now all the zeros are done because my j it's in the last, right? Now what happens is like j, right? Now I will update my I, and again I will make I is equal to j. So that means I will move this pointer j to uh, I plus 1, say. Now I will update with 1 and then 2. Similarly with this how we did with zeros, right? So this is one way we could think of, and at every time, right, we are comparing, we are checking that is there any zero or not, right, at every instant. So what could be the time complexity here? What could be the time and space complexity? So here we didn't use any specific, like any new space, right? So that's why it's order of 1 only, right? Whereas this time complexity, I could say it's order of n square. Why? It's because I'm considering two pointers, and at every instant I will go till the end. Again I'm coming back, again I will go search and till the end, again I'm coming back. This is how I'm doing, right? So that's why it's order of n square. Clear? Now, so with n square we could say it's kind of expensive, right? So is there any way that we can be able to reduce this time complexity and make it optimized? So, in that scenario, think of uh, different ways. So, there exists another pattern where we can be able to do like, so here our values is 2 0 2 1 1 0. Okay. So, here, how about if I take 3 pointers? Okay. 3 pointers. Okay. One which deals with 0, number 0. Second pointer it will deals with 1, and third pointer it will deals with 2. Okay, so here what we will do, how we will do with this 3 pointers is like, let's say 2 0 2 1 1 0, right? So let's say I call it as a pointer I, or pointer j, and pointer k. Okay, or some scenarios it's called like low, mid, or high. Okay, so these are the names which use there. So what I will do is like, initially I will start with the index I is equal to 0. Okay, so and I name it as like, so here I point I as well as j at this start index, and high at last index. Okay, that means k. Okay, so it's like a 2 pointers, right? 2 pointers we consider like, uh, basically it's like a 3 pointers, but how we do based on our problem is what differs here. So what I will do is like, initially I start with I, right? What I consider, I is something which takes care of zeros, and j is something which takes care of 1, and k is something which takes care of 2. Clear? So I will make sure not to move initially the I and k, but I will move the j. Okay, I will see that does this j has what value. So if it has the value 2, it will swap with k. Clear? That means how it is, it's 0 0 2 1 1 and 2. Okay, so this means here it's I and j are here, and k is here, right? So now I will check, so that this value is 0, right, and is clear, and this one is swapped. So I will do k minus minus, so it will come forward. Then I will again check this whatever the value that is present in the jth position. If it is 0, I saw that it is in the right position, so I will swap with I value. So I don't know that I and j are at this particular instance, so that's why I will swap with I value, because I is something which is taking care of 0, right? So how it will be, it will be like 0 0 2 1 1 2, and k is here at this index. So after swapping, what I will do, I will increment I as well as j. Clear? And again it will check this number. So okay, it is 0, so again it will swap, so it's 0, right? Now again it will move, so I here and j is here, right? When I see j here, what happens, I see 2, right? So that means I need to swap it with value k, so that's why it does a swap. Clear? So then what it happens is like 0 0 1 1 2 and 2. So after swapping, what happens, k minus minus, k is here, and then here I and j. So after swapping, I don't know what is the exact element that is here, so again I will check here. So that means j, it says okay, there is a value I know value 1. So this j is something which is taking care of this value 1, right? So okay, it's in right position, then I will move forward. That means it's j plus plus. So if k is equal to j, right, in this scenario we will say all the elements are sorted. Clear? So this is how we will do. And actually this problem, we call it as like a Dutch national flag problem. Dutch national flag. Why we call it is like that is like when we see the Dutch national flag, it has three colors. Three colors, right? So here this sort colors problem also deals with three colors, right? Three colors, and we use three pointers. So to solve this, hence it's called as this Dutch national flag problem. Clear? Dutch national flag pattern, I could say. Okay, this one. Clear? So how we can be able to solve this? When we see this, let's say in the as I said, I will consider with low, mid and high. Okay, not ijk, or okay, I will go with ijk only. I is equal to 0 and int j is equal to 0 and int k is equal to, what's the k value is the last element, right? Nums dot length minus 1. Clear? I had I, j and k, right? Now while I need to iterate, while j value, that means the value which is taking care of 1, right? If it is less than or equal to k, okay, or simply it will be easy if you guys consider this low, mid and high. Okay, so it's if mid, if it is less than or equal to high. Okay, so in this scenario what we will do, we will check what's uh, the integer that is present at that particular place, right? So here if nums of mid, if it is equal to 0, this is one scenario, right? Else if nums of mid, if that is equal to 1, right? Else that means it's nums of mid equal to 2, right? So that means here nums of mid equal to 2, right? So if nums of mid equal to 1, what we will do, we need to swap, right? We need to swap with the low part, right? Low value. So swap, here what we will swap, we will swap the values. I will write another function called swap. Okay, nums low value and mid value. Clear? Now what we will do, we will do low plus plus and mid plus plus. Clear? This is fine, right? Now if it is 1, value 1, what we are doing, we are just moving the mid, right? If I saw here, I saw this value, right, of 1. Now what it will does, the j just increments, right? It don't need anything because it knows that it's already sorted. Clear? So that's why it's mid plus plus. Okay, else in this position, if I find the value 2, what I need to do, I need to swap, right? Swap nums comma mid and high, right? I need to swap high and mid, and what I will do, I will do high minus minus. Clear? So now we will write another function called swap here. Let's say private void, that is a swap method, and integer nums comma int I and int j, say. Now int temp is equal to nums of I, right? Now nums of I is equal to nums of j and nums of j is equal to temp. Clear? So let's run this. It's done and submitting. Cool. Clear? So the here low, mid and high is some names which we use frequently, right? So for the binary search also, we are very familiarized with these names, so that's why I use this instead of IJK. Kind of confusing here, but yeah, I think you guys understand, right, what exactly is. So we will take 3 pointers for three different things, like for the value 0, for the value 1 and for the value 2. And observe, we considered this 3 is because in the question they mentioned it has only three objects, right? So three colors. So though the size is n, we don't know, but it deals with three colors only, right? So that's why we consider 3 pointers, and that's fine, absolutely. And so for every value we need to sort, right? So that's why this is one way we can be able to do it, right? Clear? I hope you guys understand this problem. That's it for this video. Thank you.